Hello, knowledge seekers. In this episode of 20-Minute Books, we delve into the cosmic connections that intertwine the fate of our planet with the mysteries of the universe in Dark Matter and the Dinosaurs. Authored by Lisa Randall, a renowned Harvard University professor at the forefront of cosmology and theoretical particle physics, this book takes you on an extraordinary journey that links the invisible dark matter to the mass extinctions that have punctuated Earth's long history. Lisa Randall, celebrated for her inclusion in Time magazine's 100 Most Influential People in 2007 and acclaimed for her other works such as Warped Passages, explores the astonishing hypothesis that dark matter could be responsible for the catastrophic asteroid impacts that lead to the dinosaurs' extinction, and how it might affect our future. If you're a scientist or a student with an inquisitive mind for science, this book will provide you with fascinating insights poised at the intersection of the smallest particles and the vast cosmos. For those intrigued by the demise of dinosaurs and Earth's early history, Dark Matter and the Dinosaurs proposes a provocative link between the cosmos and the history of life on our own planet. Join us as we unravel the dark secrets of the universe and their impact on the world as we know it. Dark Matter and the Dinosaurs: The Astounding Interconnectedness of the Universe. Introduction: Unraveling the Universe's Mysteries with Dark Matter and Dinosaur Extinction. Envision a world shrouded in mystery, a cosmos where elusive forces tug at the fabric of reality, elements that have shaped the fate of our planet and its ancient inhabitants. The demise of the dinosaurs, once thought to be rulers of the Earth, has long been attributed to a colossal meteoroid impact. However, this historical puzzle piece might be part of a larger cosmic pattern, one that involves recurring catastrophic events and the enigmatic substance known as dark matter. Dark matter, an unseen but pervasive component of the cosmos, comprises the majority of matter in the universe. Until recently, our understanding of this shadowy player has been minimal at best. But as the veil lifts, we are beginning to appreciate not only its omnipresence, but also its potential influence over our very existence. Prepare to delve deep into the nature of dark matter, tracing the origins of the universe and examining the role that both dark matter and meteoroids might have played in Earth's evolutionary saga. You'll get to explore the gravitational influences dark matter exerts on our galaxy, the surprising ways in which meteor impacts may have catalyzed life, the scientific forecasts regarding the likelihood of future meteor events. Join this cosmic journey and discover the intricate dance between dark matter and the dinosaurs, a story that intertwines the deepest reaches of space with the ancient history of Earth. Part 1. Dark Matter: The Invisible Substance Interwoven with Our Reality. Picture this. There's an unseen presence that courses through you, surrounds you, and binds the universe together, yet it eludes direct observation. Welcome to the enigmatic world of dark matter. Despite its ubiquitous nature, dark matter cannot be seen or felt. No glimmer of light betrays its existence, nor can it be touched or sensed through conventional means. Unlike the visible matter that can be detected through scent, sound, sight, taste, or touch, it operates beyond the electromagnetic spectrum, making it virtually invisible to our probing scientific instruments. Could you imagine that, even as you listen, untold billions of dark matter particles are passing through you, as intangible as shadows at dusk? It's an elusive traveler through space, indifferent to the photons that render the universe visible to the human eye. The very essence of dark matter remains a mystery. What exactly makes up this non-luminous substance is a question that puzzles even today's greatest minds. It doesn't seem to be made of the atoms and elemental particles that build the world we can perceive. It's akin to an entire unseen ecosystem of microorganisms that are critical to life on Earth. Here's a startling fact. Dark matter is estimated to constitute about 85% of all the matter in the cosmos. It's far more than just stardust. It's the vast majority of everything that has mass out there. But how are we so certain of its presence if we can't lay our eyes upon it? The secret lies in the undeniable force of gravity. Motion is a constant in the celestial dance of the universe, and gravity, that inexorable cosmic force, is heavily influenced by mass. Rewind to the 1930s, when astronomer Fritz Zwicky made an observation that would rock the foundations of astrophysics. He observed galaxies swirling at such velocities that, by all standard calculations, they should tear apart. Yet they didn't. There simply wasn't enough visible mass to generate the gravity needed to orbit at such speeds. This led Zwicky to a groundbreaking conclusion. There must be a considerable amount of unseen matter providing the necessary gravitational glue. He called this the dunkle materie, the dark matter, the specter conjured by the gravity it commands. Part 2. How dark matter weaves the cosmic tapestry of galaxies and solar systems. The seeds of a grand cosmic landscape, scattered across the vastness of space and time, were sown by dark matter, shaping galaxies and cradling the birth of stars and planets. After Zwicky's pioneering speculation on dark matter, centuries of scientific scrutiny have sought to unravel its mysteries. One pivotal discovery lies in the cosmic microwave background, a whisper of ancient light from the universe's dawn. This relic radiation, a snapshot from when the universe was a mere 380,000 years post-Big Bang, offers a glimpse into the primordial recipe of radiation, matter, and energy. Echoing Zwicky's observations and marrying them with modern research, scientists have deduced that dark matter holds 5 times the energy of the cosmos's visible constituents. Dark matter's profound role doesn't end with its abundance. It has played a critical architect in the universe's structure. Unlike its radiant counterparts, dark matter interacts only through gravity, allowing it to aggregate amidst the expanding universe's chaos. These clumps of gravity-bound dark matter became the scaffolding upon which galaxies were constructed. Fast forward billions of years, and we find the origins of our solar system. Born from a dense gas cloud's gravitational collapse, our sun ignited 4.56 billion years ago. Surrounding it, dark matter's invisible hands guided the assembly of the solar system's disk, spinning raw material into orbiting planets. But not all planets are crafted from the same cosmic clay. The inner quartet, Mercury, Venus, Earth, and Mars, formed sturdy, non-volatile cores of metals and rock. Farther from the fiery furnace of the sun, gas giants like Jupiter and Saturn grew to colossal proportions, sweeping up hydrogen, helium, and other volatile materials that would have evaporated closer to the sun's searing embrace. In essence, when we discount the sun's overwhelming mass, the outer planets, Jupiter, Saturn, Uranus, and Neptune, comprise 99% of our solar system's matter. It's a testament to the layered influences of dark matter and its gravitational prowess in sculpting the variety we observe across our planetary neighborhood. Part 3. From Celestial Collisions to Life's Genesis. How meteoroids might have fueled Earth's evolution. Imagine a time when Earth was a young realm, its surface pocked and scarred from the heavens' relentless barrage. These celestial messengers, known as meteoroids, are small pieces of rock or metal that enter a planet's atmosphere from outer space, a catch-all term for anything from meteorites to cosmic dust. During the nascent days of the solar system, an astronomical game of billiards was underway, with meteoroids constantly striking the Earth. Venturing back in time, we discern 2 significant epochs of meteoritic bombardment. The early bombardment, dating to 3.8 billion years ago, and the late heavy bombardment, occurring 500 million years subsequent. These eras have left indelible marks on our lunar neighbor, painting a pitted portrait of sustained cosmic pummeling. But why do these bombardments matter to us Earthlings? Well, they quite possibly laid the groundwork for the life that teems upon our planet today. Valuable minerals that we now excavate were delivered by those ancient celestial travelers. As Earth took shape, its densest elements sank into the core, leaving the surface bereft of certain critical materials. Meteors, freighted with iron, nickel, carbon, water, and amino acids, life's molecular precursors, replenished what the newborn Earth had forfeited. The intriguing possibility that life owes its origins to meteoroids is not mere conjecture, it's a thesis with scientific backing. The end of the early bombardment correlates strikingly with the emergence of life. Around the globe, the fossil record tells tales of thriving complexity, surging in the wake of meteor impacts. Take, for example, the trilobites entombed within China's Yangtze Gorge. These ancient creatures rest just above layers that tell a story of sudden, extraterrestrial impact. The presence of trilobite fossils and the geochemical signatures of meteoroid collision together spin a narrative. Perhaps these space-faring rocks played a pivotal role in the evolutionary leap that led to these and countless other organisms that ultimately paved the road to us. Part 4. Comets, the dramatic wanderers of the celestial realm. Gazing into the heavens, the Earth bears witness to the remnants of the solar system's formation, drifting, burning, and disintegrating as they kiss our atmosphere. Each night, a silent fireworks show unfolds overhead as about 50 tons of ancient cosmic dust and minuscule meteoroids meet their fiery end in the atmospheric embrace. These nightly sparks that embroider the sky's vast canvas are not to be confused with the more spectacular travelers of the cosmos, comets. Those are celestial nomads with luminous tails that stretch across the darkness, their icy hearts ablaze. Originating from the frosty outskirts of the solar neighborhood, comets are dirty snowballs of volatile compounds that, when warmed by the sun's rays, burst into glowing spectacles of gas and dust. Comets are divided into two groups, categorized by the length of their orbits. Short-period comets are denizens of the Kuiper Belt, a circumstellar disk beyond Neptune's orbit, rich with icy bodies and miniature worlds like Pluto. This shadowy frontier is only beginning to yield its secrets to our hungry telescopes. Journey further still, and you'll find yourself in the domain of the long-period comets, the distant Oort cloud. Named after Jan Oort, the Dutch astronomer who first proposed its existence, this spherical shell encases the solar system, a repository of frozen relics at the mercy of the sun's diminishing grasp. In this twilight zone of solar influence, even a slight nudge can send an object cascading inwards, morphing into a brilliant comet. In this vast Oort cloud, with its possibly trillions of occupants, lie the seeds of potential cataclysm. Objects large enough to disrupt terrestrial life should they cross paths with our planet. The full extent of this distant cloud remains shrouded in mystery, a puzzle that humankind must gradually piece together as we reach for the stars. Part 5. Assessing the threat, the formidable impact of mighty meteoroids. The cosmos above teems with untold mysteries and relics of ancient formation, some awe-inspiring, others carrying the might of destruction. Beyond mere specks of burning light, some meteoroids carry within them the raw energy sufficient to leave a lasting mark upon our world or even reshape it entirely. The tale of Tunguska in 1908 bears witnesses to such potential devastation. In the quiet expanse of Siberian wilderness, a modest-sized cosmic wanderer, no more than 50 meters in diameter, concluded its interstellar journey with an explosion that reverberated around the world. To comprehend the magnitude, envision a blast force surpassing the Hiroshima bomb by a factor of 1,000, churning the air with the force of 10 to 15 megatons. From as far as France, people heard the rumble of this aerial detonation. It etched its seismic signature thrice as it circled the globe, flattened forests spanning thousands of square kilometers, ignited blazes, and sent shock waves shearing through the Earth's protective atmospheric shield. And yet, it's crucial to remember, this mighty force never even graced the Earth's surface. It was an airburst event, a testament to the potential wrath of spaceborne bodies. In our modern era, humanity keeps a vigilant eye on the sky, monitoring near-Earth objects, NEOs, and near-Earth asteroids, NEAs, cataloguing those celestial bodies that wander too close to our terrestrial home. Fortunately, the thousands logged thus far don't sound an immediate alarm. We contemplate the skies with a mix of wonder and wariness, noting that even the likeliest candidate for collision, a NEO with a 0.3% chance of nearing Earth, won't brush by until the far reaches of the year 2880. Still, the unpredictable ballet of celestial mechanics, with the gravity of planets altering trajectories like courses of billiard balls, warrants continued surveillance. As of now, projects spearheaded by the United States, including the Asteroid Impact and Deflections Assessment Mission and the Asteroid Redirect Mission, strive to devise contingencies against those odds. By adjusting an asteroid's speed, we could steer clear of disaster, propelling the meteoroid on a safe detour around Earth. Essentially, these missions stand as humanity's burgeoning attempt to harness and redirect the raw, cosmic forces that could one day challenge our very existence. Part 6. Tracing the Cataclysm. Meteorites and the Timeline of Life's Upheavals on Earth. Our planet's history is scarred by periods of abrupt interruption and radical change, mass extinctions that have time and again redrawn the boundaries of life. Spanning hundreds of millions of years, 5 great extinctions have decisively punctuated the Earth's biological narrative. The curtain closed on the Ordovician period, roughly 440 million years past, with a die-off that bridged the gap to the Silurian age. Not long after, at the Devonian period's finale, 380 million years ago, another wave of extinctions swept the planet. Yet, neither was as annihilating as the Permian-Triassic event occurring a 250 million years ago, the ultimate life quencher, extinguishing over 90% of the world's species, sparing few, not even the insects. This was followed 200 million years ago by the Triassic-Jurassic extinction that claimed another 75% of Earth's dwellers. The most renowned of these cataclysms, however, imprinted on the public consciousness as the fall of the mighty dinosaurs, is the Cretaceous-Paleogene, or Capegge event. Occurring 66 million years back, it obliterated 3/4 of the Earth's species, leaving behind a world from which only a fraction of its former biodiversity would recover. What sets the KPG event apart is the telltale evidence etched into the Earth's strata. The boundary marking this extinction is a visible scar in rock formations worldwide. This geological testimony holds the clues to a calamitous impact, revealing peculiar phenomena such as microscopic diamonds and shock-transformed quartz, both markers of extreme, instantaneous pressures likened only to nuclear detonations or cosmic collisions. The KPG boundary also harbors abnormally high concentrations of iridium, a rare Earth element. Enter Walter Alvarez, a geologist in the 1970s, whose keen eye noted this anomaly. The iridium spike suggested an extraterrestrial assassin. A meteorite bearing this precious cargo had struck our planet. The accumulations were so vast that they pointed to an impactor ranging between 10 to 15 kilometers in diameter. Through layers of ancient sediment, scientists have unearthed a record of violent upheaval. The KPG extinction stands as a clear instance where a massive meteorite played the Grim Reaper, reinforcing its role as one of the grand orchestrators of Earth's long and tumultuous tale of life and death. Part 7. The elusive hunt for ancient meteorite craters on Earth. Contemplate for a moment the sheer might of a meteoroid spanning 10 to 15 kilometers hurtling toward Earth. When such a colossal object collides with our planet at breakneck speeds, upwards of 20 kilometers per second, It's more than a mere impact. It's an apocalyptic event wielding the force of 100 trillion tons of TNT, enough to dwarf Hiroshima's destruction by factors unimaginable. This cataclysmic encounter would unleash a global maelstrom, unimaginable winds, waves reaching mountainous heights, and tremors so violent they'd crisscross the globe. Then comes the fallout. The sky darkens with debris, trapping the sun's heat, and the world simmers in an unbearable oven of its own making. The aftermath of such devastation likely contributed to the K-Pig boundary, discernible by an extraordinary concentration of charcoal and soot, hinting at a combustion of over 50% of Earth's plant life. Added to this would be the poisonous brew of nitrous oxide and sulfur unleashed into the air, conjuring years of corrosive acid rain. It stands to reason that such an impactful event would leave indelible marks upon Earth's geological face. And yet, the quest to find craters from cosmic collisions is a tricky one. The scars left by meteoroids from the early and late heavy bombardment periods have largely been smoothed over by the relentless passage of time and the ceaseless work of natural elements like erosion. Craters in the seabed are exceptionally elusive, their secrets often veiled by watery depths. Despite these challenges, the hunt for the infamous crater responsible for the dinosaurs' demise was informed by Alvarez's pivotal discoveries within the KPG layer. Evidence was mounting that the impact occurred on a continental shelf. Piecing together the puzzle of ancient impacts thus became a matter of following the clues to their dramatic point of origin. Clues that, as it would soon emerge, pointed investigators to a defining epicenter of Earth's history. Part 8. Unlocking the KPG Mystery. The hunt for a crater and a cataclysmic clue. Detecting the resting place of the KPG event's perpetrator, an asteroid of devastating proportions, was akin to solving an intricate geological detective story. One piece of evidence stood out as pivotal. Any crater left by such a massive impact would likely span some 200 kilometers in diameter. This crucial starting point, supplemented by two significant clues, put researchers on the correct trajectory toward a monumental find. The first promising lead stemmed from unexpected magnetic anomalies off the Yucatan Peninsula, hinting at subterranean secrets. In the 1970s, Mexican oil company Pemex had conducted magnetic surveys that revealed disturbances tracing a nearly perfect circle, approximately 180 kilometers wide. Enter Glenn Penfield, an American geophysicist, and Antonio Camargo, a Mexican geologist. Their presentation of these magnetic irregularities at a Los Angeles geophysics meeting in 1981 failed to connect the dots with the ancient KPG strike. Fast forward to 1990, when an academic team from the University of Arizona, led by graduate student Alan Hildebrand, scrutinized an intriguing KPG sediment layer in Haiti, abundant with the signature shocked quartz and iridium, suggesting the true impact site lay less than 1,000 kilometers away. The puzzle pieces lay scattered, waiting for integration. At a scientific conference, serendipity played its role. Carlos Bayars, a journalist with Houston Chronicle, in attendance, had a recall moment, connecting Penfield's enigmatic findings of years past with the present search for the crater. Armed with this insight, Hildebrand and his colleagues examined Pemex archived geological samples, drawn directly from the mysterious undersea structure. Their thorough investigation yielded a jackpot. The core samples revealed not only the distinctive shocked quartz, but also an appropriate layer of iridium, dating back precisely 66 million years. This confirmation culminated in 1991 with a published revelation in the journal Geology, solidifying the site's identity as the Chicxulub crater, named in honor of Chicxulub Puerto, a modest fishing village stationed near this newly unveiled witness to a cosmic collision that altered Earth's destiny. Part 9. The Cosmic Rhythm. Probing the pattern of celestial impacts and mass extinctions. Amidst the dance of celestial bodies and the geological ebb and flow of Earth's history, a pattern begins to emerge. a rhythm of destruction and rebirth that casts a shadow every few tens of millions of years. The Chicxulub crater, a giant scar etched by a heavenly stone, is but one in a tapestry of craters that pepper our planet's surface. These craters, along with fossil records, may be the cryptic tokens of a periodic cycle in cosmic impacts and the mass extinctions they trigger. A curious regularity has surfaced from the depths of time, extinctions every 30 to 35 million years, suggesting a clockwork of cometary visitations. This pulse of life and annihilation was first proposed by Michael Arthur and Alfred Fisher from Princeton, who in 1977 noticed a striking 32 million year cycle in the rise and fall of biodiversity. Their conjectures were later supported by researchers from the University of Chicago, who in 1984 narrowed the cycle to every 27 to 35 million years. More recent studies conducted by the University of Kansas, in conjunction with the Smithsonian, uphold this conjecture, reinforcing the notion of a recurring extinction event roughly every 27 million years. The crater record echoes this biological beat. A 1984 inquiry by the University of California, Berkeley, into 11 craters posited a 31 million year interval. That same year, New York University's scrutiny of 41 craters identified a similar 31 million year cycle. Fast forward to 2004, and a comprehensive study from Kyoto University examining 91 craters over 400 million years discerned a 37.5 million year pattern. It seems the whispers of an impact cadence are not merely phantom echoes. The larger and more devastating impacts appear to have been delivered by high-velocity, long-period comets, hurtling from the frosty reaches of the Oort cloud. If such a proposed regularity proves true, it would add a fascinating chapter to the story of Earth's geological history, one where the pulse of life is periodically reset by the icy heralds of the cosmos. Part 10. Navigating Cosmic Tides. The gravitational dance behind comet showers from the Oort cloud. The mechanics of the universe often mirror the familiar. As the moon's gravity influences Earth's tides, so too does the gravitational might of the Milky Way sway the motion within our solar system. The journey of the solar system, as it voyages around the galaxy's heart every 240 million years, is not a lone trek through the void, but a waltz with the galactic tide, a subtle but profound gravitational force exerted by our spiraling Milky Way. The immense influence of this cosmic tide is felt most at the fringes of our solar domain, particularly within the distant Oort cloud. As the galactic forces ebb and flow, they stretch and compress this celestial boundary like a cosmic accordion, potentially nudging its icy inhabitants closer towards the inner solar system, teetering on the brink of a gravitational pull exerted by the sun. This, however, is only a prelude, an initial nudge, setting the stage for further disruption, not enough on its own to explain the suspected periodic comet showers emerging every 32 million years or so. The full picture might be found in the peculiar path our solar system charts through the galaxy, an up and down bobbing motion across the Milky Way's galactic plane. These oscillations, akin to the rhythmic undulation of a carousel horse, see the sun and its entourage traversing the galactic disk's thickness, crisscrossing its median every 32 million years. If during these crossings the solar system encounters an increased density of matter, a gravitational crescendo could ripple through the Oort cloud, rousing its slumbering comets. What mysterious form of matter could exert such influence during these galactic plane transits? A possible culprit emerges from the astronomical shadows, dark matter. This invisible substance, entrenched within the unseen fabric of the cosmos, could be the gravitational shepherd herding comets from their distant cloud towards a dramatic destiny with the inner solar system. Part 11. Are dark matter disks the astronomical trigger for Earth's comet impacts? Now we approach the cosmic crossroads, where dark matter's enigma intertwines with the destiny of our planet. Could this shadowy player be the missing link in the pattern of massive meteoroid impacts every 32 million years? According to the author's proposition, we might be on the brink of unraveling this mystery, with dark matter at its heart. The diversity of particles we currently know, from quarks to neutrinos, opens the door to the possibility of different dark matter types. Enter the concept of self-interacting dark matter, a form of this elusive substance that could clump together under its own attractive force, increasing density and possibly influencing the structure of galaxies. Imagine the Milky Way, not just as a spinning disk of stars and gas, but also harboring an inner disk made of dense, self-interacting dark matter. This could provide a gravitational nudge potent enough to dislodge comets from the Oort cloud's icy embrace as the solar system oscillates through the galactic plane. A formidable dark matter disk encountered roughly every 32 million years. Our celestial neighborhood passing through such a dense region could be the catalyst needed for primed comets to begin their fateful journey toward the heart of our solar system, potentially impacting Earth. But theories must be tested, and the Gaia satellite might hold the key. This spacecraft, tasked with surveying the stars, will provide precise measurements that could confirm or refute the existence of a high-density dark matter disk at the galactic plane's center. When Gaia's data returns in 2018, with a star-studded map of velocity changes and spatial arrangements, it could indeed verify the intriguing hypothesis linking dark matter to a cycle of devastating impacts on Earth. So, as we await Gaia's findings, we stand on the precipice of potentially groundbreaking astronomical insight. Dark matter, the silent sculptor of galaxies, may also be an orchestrator of cosmic events that have shaped Earth's geological and biological epochs. Only time, and the light from a billion stars, will tell whether these celestial mechanics hold the secrets to Earth's prehistoric comet showers. Final summary. Invisible and intangible, dark matter is an omnipresent force in the universe, escaping detection while shaping galaxies and celestial bodies. This ghostly matter is not merely the backdrop for the stars. Its gravitational influence was pivotal in the clustering of matter that eventually birthed our solar system and the planets within. But dark matter's role may extend far beyond cosmic construction. It could be a cosmic courier, delivering essential elements to seed burgeoning worlds with the potential for life. Meteoroids, hurtled from the distant reaches of the Oort cloud, possibly driven by gravitational disruptions linked to dark matter, carried water, organic material, and perhaps even the building blocks of DNA to our young, lifeless Earth. Through galactic motion, periodic comet showers, and the fateful impacts on Earth's surface, such as the one responsible for the KPG boundary, dark matter might indirectly be responsible for some of the most significant events in Earth's history, including the extinction of the dinosaurs and the kickstart of life as we know it. As we stand on the frontier of understanding, with missions like Gaia poised to peel back another layer of the galactic mystery, we inch closer to confirming how deeply intertwined dark matter is with both our planet's past and the cosmic tale at large. Thank you for joining me today on this journey of learning and discovery as we explored the insights of another thought-provoking book in our growing library of knowledge. If you've enjoyed our time together, please take a moment to follow our podcast, give us a 5-star rating, and share 20-minute books with other knowledge seekers. Your support truly means a lot. Don't forget to join me again in the next episode, where we will delve into another enriching book. Until then, happy reading and happy listening.